right, this is our last page, page 4 of section 14.2. So if you haven't already, please do the classwork. Number 4, calculating the median, and then you can read the definition and come back. All right, welcome back. So the mode you found out is the data value that occurs most frequently. So remember when we were talking about the size t-shirts, you know, the sizes, this would be something where the mode would be important piece of information. You want to know how many people need size large or extra large. Same with shoe sizes. So when you're ordering things like that, the mode might be the more important than, let's say, the average. What good would the average shoe size do for you? Not much of anything. Okay, so it is possible for the data set to have more than one mode. If no one value occurs more often than others, then the data is said to have no mode. Okay, so we're going to find the mode for each of the following distributions. So when we look at this, we're just going to try to scan the data and see if anything occurs more than once. Well, I can see 5 occurs more than once. Everything else is just single. So we would say mode equals 5. Okay, on to the next one. As I'm going here, I see there are 2 3s and there are 2 5s. So we're going to call this bimodal, meaning 2 modes. Okay, bimodal, and they are 5 and 3, 3 and 5. Okay, so now go ahead and pause the video again and try your problems, number 4, number 30, and number 36. And then you can, I have a feeling you need a little bit of help on this classwork example for the semester grade reports. Yes, go ahead and don't do number 30, okay? Just do number 4 and then come back. Okay, so we're going to now talk about box and whisker plots. So here is what one of these looks like. And basically it's a picture of the data that kind of tells you where the low, the high, and the center is. So the minimum is obviously going to be your smallest data point, okay? So that's how your smallest data value is marked. Smallest data value. And then your maximum, I think you could figure out there that that's going to be your largest data value, okay? Then the 25th percentile. That means that 25% of the data is below here, falls between the minimum and the 25th percentile, okay? So we'll say right here is 25% of the data, okay? And then, so this data value right here that we could just put right here, we would say 25% of the data is below this value. Okay, the median. What is the median? Well, the median means it's exactly in the middle. It cuts the data in half. Remember that? Okay, so it's also called the 50th percentile. And that would be because 50% of the data is below and 50% of the data is above. Okay, so the 75th percentile, that value right there, says that 75% of the data is below this value. Okay, so 25% of the data remains in here too. So what percent of the data is in that box? If 25% here, 25% here, all together you have to have all of the data. So that has to be 50% of the data is in that box. Let's sneak that part in. 50% of the data. Okay, that kind of puts it all together. Okay, so this is the minimum value, this is the maximum value. Okay, let's move on to this problem that takes a look at one of these plots. A college placement office has made a comparative study of starting salaries for graduates in various majors. The box and whisker plots below describe the starting salaries for business, education, engineering, and liberal arts. Okay, so which major in general receives the highest salary offers? Okay, so if we look at liberal arts, we see that your lowest salary is 20, your highest salary is 49, and 50% of the data is between 24.4, so 24,400, and 30,000. Okay, that's where it is. So as we look at all these, we can kind of compare them. So who has the highest salary? Well, who goes over here to the right the most? Engineering is 38 for its box, whereas business is 35.8. And here engineering goes up to 40.5 and business goes up to 45. Okay, so in which major in general receives the highest salary offers? Well, it appears that most of the people lie in this range from 29.2 to 38. So we're going to say engineering does. I mean, there are some people who lie in this range, but more people lie here. So we're going to say engineering. Okay. All right. Does liberal arts or business have higher median salaries? Okay. So what are we looking at? Well, we're going to look at the median salary of liberal arts. Median is right. Remember, this is the median right in the middle. So liberal arts is going to be 27,000 is their median. Okay, and then let's talk about business. Business, their median would be 28. Okay, so who has the higher median salary? Well, business does. Okay. So last question, what is the significance of the shorter whiskers in the engineering plot? Okay, well, when we look at engineering here, okay, we see that its salary range goes from 26 to 40.5. So everybody is in that range. Small area. Whereas like if we look at business, they go all the way from 21 to 45. So they have a much wider spread, whereas engineering is very concentrated. You may not go up as high or go down as low. You kind of stay in that central area. So the shorter whiskers means that the salary range is smaller. Okay, that's what it means. More concentrated or starting salaries are more concentrated around the median. Okay, so that's it for this page, but I wanted to give you a little bit of a hint for your classwork. So let's take a look. On the back page here, when you're doing grade point averages, let's just make sure you know how this works. Many colleges assign numerical points to grades as follows. And A is worth 4 points, B is worth 3, C is worth 2, D is 1, and F is 0. Your grade point average, GPA, is computed by multiplying the number of units or credits for each course by its numerical grade. Adding these products and dividing by the number of credits, use this method to compute the GPA for the semester grade report. So you have a class that's worth 3 units and you got a C in it. So you go up here and you say, okay, a C is worth 2 points. So you're going to multiply the credits times the grade. Okay, so credits times the grade. So you get 3 times 2 or 6. Okay, then for health, you have 2 units, 2 credits, multiplied by an A, which is 4. So 2 times 4 is 8. All right, then you're going to come up with a total here. Okay, so when you add up to find your GPA, it's going to equal the sum of the credit times the grade all over total number of units or credits. They call them credits. Okay, so you're going to get this total here, and that's what's going to go in the denominator, and then you're going to continue this process of putting down the value and multiplying it by the credits, and then you'll total that, and that will go here in the numerator, and then you'll divide them and you'll see what the GPA is. So hopefully that'll help you to finish that classwork. That concludes section 14.2.